Okay, so now we're going to talk about squares, adding up squares. So 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared. So this is kind of interesting. How do you want to think about, what do you think is an interesting way to think about adding up these squares?
Well, we can't really do it like the triangle way because
it's not a very easy triangle.
Slope decreases over time.
Yeah.
Well, that's interesting. What could you do if you wanted to approximate this as a right triangle?
Well, maybe you could lift it up a little, and then add the point right here. Do this.
Okay, you could do that. That'd be one idea.
Well, I have a different idea for approximating it.
Okay, what would that be?
Since, well, we have squares, we can stack squares.
And now we have a pyramid.
Oh,
Pyramid.
making a pyramid. Okay.
And the area of a pyramid is 1/3 the base times the height.
The what of a pyramid?
The volume of a pyramid.
Okay. The volume of a pyramid
So,
is 1/3 base times height.
well,
okay, that's an interesting
and then
idea.
our approximation for this would be 25 times 5 high. So this is 125 thirds.
Okay, and what is this approximately? What's the integer that's closest to that?
Well, 123 is going to be 41 times 3.
Uh-huh.
So this is pretty close to 41, but it's actually closer to 42.
Okay, so we say there's about 42 cubes in here. How many are there actually?
Well,
Let's see, so
it'd be
25 plus 16 plus 9 plus 4 plus what? 30 plus...
well, 10, 10, 25.
This is 55. Is this a good approximation? Because it's the actual... We thought 42 and but the actual was 55.
Okay, so how close did we want to be?
Well, 55, 49 is, square root of 49 is 7.
Mm-hmm.
So if we're 7 or less,
Okay.
but we're not.
So this is a bad approximation.
So this is 13 away, actually.
Oh, so this one, it turned out it was a little bit too far away. Huh, but it looks like a pretty good geometric idea, actually.
Yeah.
Maybe if we get bigger and bigger sums, this would get closer and closer.
So what do you think it would be for 10, for example?
So 10. We have...
Well,
so the area of the base would be 100.
100 times the height 10. So be 1,000 over 3, which is close to 333.
Okay. Now, here is a formula as well, by the way, believe it or not. And the formula for the sum of squares. It's not important to know why. We've actually done a project on it, believe it or not. But it's n times n plus 1 times 2n plus 1 all over 6.
So I guess here n would be 10.
Yeah, n would be 10. So we'd get 10 times 11 times
21?
21.
Over 6.
All over 6. So 5 times 11 and then times 7.
Well,
And so it's going to be 77 times 5.
or you could think of it as 35 times 11.
Oh yeah, 35 times 11 too.
350, 35.
Uh-huh.
385.
Yep.
So
385.
385. We are... Seems like we're 52 away.
And that's definitely, well, this is, I don't think, a very good approximation.
Okay.
Because we're, even if you make a very rough approximation, because, no. This one is close to 20 squared,
Mm-hmm.
and we're off by 50-ish.
Yeah, okay.
So is there a different way we could do this?
Darn.
So the pyramid idea doesn't really work here.
Well, it looks pretty good though,
Yeah.
doesn't
Yeah.
it? I mean, it
What
looks
is
like,
going wrong?
yeah, what's going wrong here?
Is there a different way we could make the pyramid? Maybe.
Well, this is nice because it's base times height, and then we divide by 3.
So what can we do?
We're also, by the way, not super far away. So
Yeah.
it's like, maybe this isn't a good approximation, but it's also not necessarily a horrible approximation.
Yeah.
Should we try it for 100 and see what happens?
Okay.
Alright, what happens with 100?
Well, you get. If you get 100, you get 10,000 times 100. Yeah. So you get. Well, 1,000,000 is close to 999,999,
Uh-huh.
and that would be it would be 5 threes. Or 6 threes.
Alright, so that's our approximation. If we were going to add the numbers up to 100, my other formula was 100 times 101 times 201 over 6. Maybe we should just do that on the calculator real quick.
Let's see on the calculator.
Okay. So 100 times 101 times 201 divided by 6 is 338, 350.
338, 350.
Oh, we're still off by like 5,000.
Yeah, we're off by 5,000.
But it seems like the approximation is getting worse with the bigger numbers.
Okay.
Hmm.
But the geometry here sure looked nice, didn't it?
Yeah.
All right. Do you want to go to an example with cubes, or do you want to try to figure out what's going on here?
Let's try to figure out what's going on.
Alright.
Okay, awesome. Let's do that.